Okay, so we have a 0.797 gram sample of iron reacts with oxygen to form a 1.132 gram metal oxide. What is the formula of this metal oxide? I'm going to start by writing down this information. So we have a metal oxide. Which metal is that probably going to be? Well, we know it's reacting with iron. It's probably going to be iron because we don't just change the elements from one into another. So I'm going to write this as 1.132 grams FeOX. And this is saying this is some iron oxide that we don't know exactly the formula of, but we will be trying to figure out. And then we have 0.797 grams of iron. Okay, now we know because of the conservation of mass that the amount of oxygen, so we need to know what that is. The amount of oxygen here and the amount of iron we have need to add up to this total mass of the iron oxide. So if we know the mass of the iron and we know the mass of the iron oxide, the difference between those is then going to be the mass of the oxygen. So we can go ahead and subtract here, and we can find that we have 0.335 grams of oxygen. Okay. Again, this step is not something we've looked at before, so if this is a bit confusing, feel free to go back and rewatch as you need to. But this is what we'll be doing in lab very shortly. So at this point, we have a mass of iron, we have a mass of oxygen, and from there we're going to find the formula. Okay, so we've done this already. I would recommend go ahead and pausing the video here and seeing if you can do the rest of the steps, and then watching to see if you get the same result. Okay, so for the iron, we have 1 mole of iron is 55.85 grams. Again, you should be able to find this from the periodic table. And we do the math there, we get 0.01427 moles of iron. And down here for the oxygen, we have 1 mole of oxygen is 16.00 grams. And we do the math here, we get 0.02094 moles of oxygen. And then we ask ourselves, which number is the smallest? And of these two numbers, the smallest is the 0.01427. So we divide each of these by that number. This will be, by definition, 1 for the iron. So we don't even have to type that in, right? We know it's going to be a 1. And this 1, so we divide by 0.01427, and I get 1.47 moles of oxygen. Okay, that is not a whole number. We want to have a whole number. So, so what do we do there? We think about what can we multiply 1.47, what can we multiply by 1.47 to end up with a whole number. And maybe a better way of thinking of that is what number are we close to that we could do that to. So don't try to figure out 1.47, but think about, is 1.47 close to something that can easily be turned into a whole number by multiplying by another whole number. And I would say it is very close to the number 1.5. So what would we multiply by 1.5? Maybe a 2. So times 2 times 2, we get 2 moles of iron up here. We get 3 moles of oxygen down here. Just a reminder, when you do this, whatever you're multiplying by down here, you need to multiply by up here. So you're multiplying by 2, so this becomes a whole number. But then you have to do the same thing up here because we are still dealing with this ratio. So our formula is then going to be Fe2O3 based on these calculations.